Hello. Good afternoon, everybody. Can folks in the back hear me okay? I'm getting a thumbs up from our colleagues at Buff State and many other institutions who are represented here today. My name is Jamie Spiller, one of the hosts of the event today, the Dean of the Graduate School at the College at Brockport, and have the great honor and pleasure of welcoming everybody to Brockport today. Welcome to all the students who are here presenting or attending other sessions, to the faculty who are chairing panel sessions and attending with their students, both from Brockport and elsewhere. Very warm welcome to those of you who have traveled from afar, and especially on a day, on April 20th, that it snowed in the morning. I hope nobody had any tough driving on a day with snow. Now, I know our keynote speaker, Dr. Tim Killeen, I was speaking with yesterday and learning a little bit about his specialty in high atmospheric physics and chemistry, and he may say that I'm wrong in this theory, but my theory is that the incredible congregation of mental power and energy has set off some sort of the harmonic resonance has set off some sort of gravitational waves that have disturbed the upper atmosphere and brought the snow down upon us all. Or maybe it's just upstate New York. I like my earlier theory. But thank you for coming today. Before I slip into a little bit of a kind of professorial lecture mode, I want to briefly thank many of the people who made this event possible. First of all of you who are here and participating today, and all of your faculty who have worked with you to help prepare you, mentor you, and advise you in working on your research projects and your presentations. I want to thank, starting with President John Halstead, who I'm going to have the pleasure of introducing in a minute, who has provided the executive leadership and support for graduate education and for celebrating scholarship at both the graduate and undergraduate level on campus and providing the resources for conferences such as this. I'd also like to thank Provost Dr. Ann Hewitt, soon to be President Dr. Ann Hewitt, for her strong support for events like this as well. I haven't seen Dr. Susan Seam. I hope she's in the audience too, who, as a colleague last year, gave so much support in launching the inaugural graduate conference last year. Quick thanks to the Basque food staff who've provided the food, to the events planning staff that have helped to help us plan the event, to the marketing and communications folks who've put together some of our web material and the print material that you have, our IT staff who are video streaming here and in some of the other classes, who have helped to ensure that our computers and PowerPoint projection systems are working. I hope that they have worked for everybody today. If they have not, my apologies, and I take responsibility for that. Thank you to the graduate school staff who are also in attendance today, and perhaps there are some of you out there in the audience who are newly accepted graduate students or prospective graduate students that we've invited to this event. And a very special thanks to the core of dedicated people who have gone above and beyond 2 years straight now in putting this conference together, and putting it together this year just 10 days after, last year 4 days after the college put on its signature event called Scholars Day, which is an event about twice the size even of this, of undergraduate and graduate research and scholarship throughout the college. So those folks have put in a lot of long, hard hours, and I hope that these folks that I'm going to name are going to be as satisfied and happy to relax tonight as I am. First, Steve Lewis, our indispensable IT guru, who has helped to put together our registration web portal and other web-based communications. Kristen Dauenhauer, Kim Remley, and Colleen Donaldson, thank you folks for doing so much. And Adrian Safar, who's also going to be speaking in a moment, a graduate student volunteer who's helped to make this conference possible. Now, why have these folks done so much to make this event possible, to support this event? I think they've done so from President Halstead and including all of the people who I've just mentioned, because we're all committed to the educational mission of this college and of the many institutions represented here today. And if there are in fact students in the audience here from the whole conference proceedings, you represent more than 30 universities today. In fact, 35, I think, universities from... Yeah. This is not only Brockport and our regional SUNY partners. There are representatives from CUNY down in New York City, other New York City institutions. We have some folks from Binghamton, University of Albany, Pennsylvania, Ohio, Southern Ontario, Canada. So thank you folks who crossed the border and spend as much money as you can in upstate New York, please, while you're visiting. We're trying to pitch this as an economic development experience too. So all of us, we've worked to put on this conference because we're committed to the educational mission of this college and the many institutions represented today. And in that, we feel that experiences like this help fulfill the special educational purpose of master's level education, that intensive preparation for professional career and PhD study. Now, how does that master's level education, how is it distinctive from undergraduate education? Well, whereas undergraduate, I think of it as an experience of wide-ranging educational exploration, of synthesis across the disciplines. Graduate education is inherently a deep immersion in a disciplinary body of knowledge and a sharp focus on specific methodologies. It's also the application of that learning in advanced and even original research or artistic activity. It's not just the immersion in, the focus in, and the application of, but it's also the presentation of that work for professional evaluation. And that's what's happening here today. So what all these committed people know is that scholarship across the disciplines is in one respect an individual exercise. Individuals like all of you developing your academic expertise and applying your creative genius in your own ways, in your own research projects, in your own scholarly endeavors, in your own artistic activities as well. But scholarship is also a community endeavor, because new knowledge and credible innovation only come when individuals have their work peer-reviewed, evaluated by communities of like professionals, questioned, challenged, and I think we can only hope endorsed with the profession's seals of approval. So this community vetting process is as much the essence of scholarship as is the individual creative effort that you have done by yourself or sometimes in teams of researchers as well. So this university and the many people who made this conference possible did so because they want graduate students to carry their academic work closer to fruition. Maybe that fruition is submission for publication. Maybe that fruition is publication. Maybe that fruition for our MFA dance colleagues here is having your choreographed work shown in a commercial or public venue, whatever it might be. That we want to help you bring that work closer to fruition by engaging in a process of community evaluation. And you're all part of that community. It's not just faculty, it's you students as well. That's what you're training for. So I encourage you to embrace this process by today being open to questions. Be open to insightful commentary by others. Welcome not just the favorable, friendly ones, but welcome and look forward to those challenging, critical questions as well. And freely give that in return. And please do so at as many presentations as possible. Right? You've all come here, and I've hoped that we would be able to provide you an opportunity to have as much audience as possible. And part of the deal there is that you become audience for others. So please, during the next session, attend sessions, whether that's panel sessions or posters. And I would urge you to reach across the disciplines too, because in doing so, it often will spark creative insights that you can bring back to your own work, as well as seeing collaborative possibilities across the disciplines. So one last point that I want to make is that the people who have mounted this conference understand that graduate education also has broader communities of interest and broader communities of commitment as well. Universities are not ivory tower silos. They're engines for intellectual enrichment, civic improvement, and economic development. Remember, Canadians, please spend your dollars. Economic development of our broader societies. The work on display here shows that this is true for all types of graduate institutions. Public institutions, which are expected to provide that value to the states that they're in, but also private institutions, PhD granting institutions, and comprehensive colleges. Right? We're all doing our part here today in serving these broader communities. And after you've done that hard work, after you've done your good contributions to the community of scholarship here and to the broader communities, I invite you to go to one of the 2 concurrent professional development workshops. That's the last session of the day. One is on career advice and insights. That we have 2 alumni and a career service professional who are going to be available in a big question and answer session. And we also have a session on pursuing PhD study, in which we have a faculty member from University of Buffalo, a dean, a soon-to-be interim provost of Brockport speaking there, as well as 2 other faculty. I invite you to do one of those. And after that, we're going to reconvene in this room for a post-conference reception. I hope those of you who are able to will join us in that. Really quickly, there's an evaluation form in your folder. If you get the chance to fill that out, there's going to be a box right out by the check-in area that you can leave that there. You'll also find in your folder an invitation to submit your work to Kim Myers online. There's Kim. She is the master of our online digital commons platform. You could have your PDF of your poster or your PowerPoint slide presentation or a edited finished product of written work submitted that can go up on a online platform and become part of your electronic academic profile and resume. You can get Googled and somebody will Google you, and it might not just be that Facebook picture of you, dancing with a lampshade, but it also might be your academic work on digital commons. For those of you who are going to the sponsored research workshop right after this luncheon, that's going to be in room 104 Edwards. And last, anybody who has special transportation needs, there's some people who've come from afar, and I know you've made your way from Rochester here by taxi or whatever. If at the end of this luncheon you want to come and just touch base with me, I'll see if I can help connect you with others who may be able to give you a ride back into Rochester. So thank you again for coming, and it's my great pleasure to introduce Dr. John Halstead, President of the College of Brockport.
Thank you, Jamie, very much. Pleasure to be here today. I'm still reflecting on your premise, your theories about the weather here. I'm not a meteorologist, but I was born in upstate New York. I've lived coast to coast. And I want to tell you, I think it's the upstate New York thing. I don't know about the other esoteric theories that Tim is putting upon you here and others, but just yesterday we were celebrating honors, academic honors, awards here, student leadership earlier in the week, and to give some credence to the weather theory, there's a big fan sitting over here. The temperature dropped about 30 degrees, and I'm not blaming those of you who have come from Ontario. We welcome you all. Well, if you thought there would be a free lunch, there isn't. If you thought the president wouldn't welcome you to this conference, you're wrong. I want to do that, but I also have a message about the role of the comprehensive colleges. I'm a product of the liberal arts, Colgate University, a couple large land-grant universities, Michigan State, Ohio State for graduate work, a medium-sized research university, University of Maine, Jesuit colleges. Yeah, I've been in the field for a long time. This is my capstone, and my capstone will continue for several years. But the reason I call it a capstone is to say, yes, it is my last assignment in higher ed, but it also says that I am still learning. And I say to our students, each and every day is a learning opportunity here. So I've learned so much in the sessions, the poster presentations today, as I do at our Scholars Day, and I want to mention that as well. But I want to first and foremost welcome our students. It's all about students and your success here, undergraduates and graduates. Our faculty and our staff that are instrumental in these sessions. And I want to give a special Brockport welcome to Dr. Tim Killeen. Tim is president of the SUNY Research Foundation and SUNY Vice Chancellor for Research. I've known Tim for about 9 months now. We sat together at SUNY presidents and chancellor meetings, and we have had an ongoing conversation. And I'm going to allude to some of that because I think we're very much on the same page. And Jamie, to establish this last year, and now the second annual gives it a cachet, I expect we'll have it be the 30th annual someday, just as we celebrated our signature event, our 30th Scholars Day, just a couple weeks ago. So why is this conference so important? And please continue eating wraps, cookies, soup, whatever you have, because you know, what I may do is just go through my remarks, open up the PowerPoint here and give a scholarly talk, which Tim had intended to do today, but he is much more poised to do that today. So why are we here? Why have we brought together scholars internationally, across SUNY, across other institutions, private and public alike? Well, we think the comprehensive colleges have a special place, and we are sponsoring this intentionally to showcase our role within research as well. And again, from day one that I've met Dr. Colleen, we have talked about that special role. It's important on many levels as we look at the landscape of higher education. On higher education training in the 21st century, public policy, workforce development, and the students who have been educated, yes, at our comprehensive colleges are able to contribute in many ways to the national economy. This may very well be the next big idea of SUNY. Our Chancellor, Nancy Zimpher, who's been here for a number of occasions, our diversity conference, the development and announcement of new facilities on our campus. But as I've talked to Chancellor Zimpher, she's big on big ideas and big data. The one we talked about most recently was April 3rd, when I convened my colleagues in the comprehensive colleges, the 12 others within SUNY in Syracuse. And we talked about the whole notion of human capital and capturing human capital and the importance of that. It might very well be the next big idea. In that meeting, I used a book by the name of The Forgotten Colleges, and it talks about the role of the Askew institutions as well as the land grants and others. And that's important discussion. It's Dunham's book, The Forgotten Colleges. And I don't want to alienate anyone at research universities. I'm very proud of my MA and PhDs. But you have a special role in the development of doctoral level students. You support research. You support patented innovations. And just the other day I was over co-chairing a meeting at RIT and the importance of research, workforce development, the whole plethora of colleges, from community colleges to comprehensive to research. You have a very important stake in the ground, but we do as well, and it's a middle ground. It may be those forgotten students, those forgotten colleges, as Dunham spoke about way back when I was in college in 1969. At Brockport, in this conference, we have all heard and will continue to hear this afternoon presentations by all of you, intellectually rich, professionally skilled, civically minded, engaged citizens. You are enriching the scholarship and enriching our knowledge base. You are presenters and exemplars here as well. Some of the best master's level trained, advanced professionals and research ready candidates for PhD programs. I am impressed as I've gone to a variety of programs this morning. I'm pleased to be in the presence of so many great scholars across the broad spectrum of colleges and universities in the Northeast and Canada. This morning's papers and poster sessions, as I said, have been tremendous. I somehow feel like I'm in a postdoc experience here. Let me just digress for a moment again. In addition to the big ideas, Dr. Colleen and I have also talked, and he also had a very engaging conversation with our faculty, our deans, and our provost last night. The importance of the STEM fields, the importance in the growth and development of the STEM fields. That is another place that we can have a very, very rich conversation here at the College of Brockport. We have also surfaced the idea of hosting a conference on comprehensive colleges and the role of research. And I've talked to not only our chancellor, but also Muriel Howard, the head of ASCU. We think there's a place for ongoing discussions across the spectrum of higher education. But now I'd like to turn the microphone over to Adrian Safar, another key member of the Conference Planning Committee, as well as a student in our MFA dance program. It's only fitting that one of our graduate students will provide the introduction of our keynote speaker. That's the Brockport way, students first. Welcome again, Adrian. Welcome to the podium.
Thank you, Dr. Halstead. Universities are seen as producers of theoretical knowledge that others can use to create prosperity. It is arguable none have traditionally exemplified this role better than the intellectual powerhouses represented by American universities. Over decades, American universities have transformed their role considerably. They have embraced the practical application of knowledge in a much bigger way than before. In the process, they have become engines of growth, producing research that drives new industries and products. Our SUNY system stands among its peers in these historical times of economic instability and civic malady as a beacon of excellence and a prominent global leader of scientific research funding and high technology economic innovation and development. Since 1951, the SUNY Research Foundation has served as an engine of New York's economy, as an engine of the world economy. As the president of the SUNY Research Foundation, the largest, most comprehensive university-connected research foundation in the country, and vice chancellor of research within the SUNY system, Dr. Tim Killeen has a track record of advocating for sponsored programs, administration, and innovative support services to SUNY faculty who are making groundbreaking discoveries every day in the areas of nanotechnology, biotechnology, materials science, high-speed computing, and many other fields. Dr. Killeen has committed himself to ensuring that the Research Foundation exceeds all expectations of accountability and integrity, and cementing the Research Foundation as an organization intensely committed to its roots, enabling and developing the research potential of our state's great public university system. It is Dr. Killeen's support of the SUNY faculty to conduct sponsored research and commercialize technology and facilitate the transfer and sharing of intellectual property that has driven SUNY to the top as a global leader of research and scholarship. Today's speaker has been the center of growth of basic, transitional, and clinical research. His interaction with campus presidents, provosts, vice presidents for research and economic development, deans, faculty, students, and SUNY leadership have driven the implementation of innovative programs, initiatives, resources, policies, infrastructure, investment, and business practices. He has been the National Science Foundation's Assistant Director of Geosciences and was a Lyle Research Professor at the University of Colorado. In 2007, was elected to the National Academy of Engineering, and from 2000 until 2008, Dr. Killeen served as director of the National Center for Atmospheric Research, a premier atmospheric and climate change research center in the world, and one of the most cited research centers in its fields. He spent more than 20 years on the faculty and in the administration at the University of Michigan, Ann Arbor, and has been the principal investigator on numerous theoretical and experimental investigations, authoring over 150 publications. Dr. Killeen has established several significant new programs, has been active in promoting NSF's international programs, has served on various White House committees and task forces, has testified frequently to Congress and to the executive branch, and was chair of the IGFA, a 25-member international group of funding agencies for global change research. His experience with excellence and dedication to our global future is clear and emanates tangibly from him in conversation. I bid you all a good afternoon and thank you and commend each of you for your dedicated research and passionate focus at this year's master's level graduate research conference here at SUNY, the College at Brockport. Please join me in welcoming, in the spirit of research and scholarship, our keynote speaker, Dr. Tim Killeen, as he shares with us his thoughts on and experience with national and international global change research.
Very good. Very good job. Good afternoon, everybody. And I got to get my system up here second, and it is indeed a strange atmospheric phenomena that's in place that I'll tell you about over a beer perhaps later on this evening. But let me see if we can get the projector up. It's warming up. I'm normally standing between you and lunch, but right now I am lunch, right? So here it comes. The other screen, okay. Well, maybe we could start using the other screen, because I don't want to, some of you are going to have to, oh, here it is, okay. So yes, I want to talk about national and international global change research. But the ultimate message is going to be to the graduate students here, this is your time. This is now on your watch. All of your talents and skills, no matter what your background is, what you've learned, this is the time for that engagement, deep engagement in societal good, whether it's in biophysical research, space science like me, or dance, or ethics, or poetry, whatever it is. This is your time, and it's on your watch. And I want to give you a sense of why I think that's the case through my own perspective, which was really formed by being at NSF the last 4 years, and being in charge of a directorate that did research into atmospheric, oceanographic, and earth sciences. So Earth systems is what I want to talk about, understanding the planetary substrate platform on which all of life exists, and all we need, the air, the water, the food, etc. And I'm going to start with this little picture, and turn the lights down, please. So this is what it would look like if you were standing on Mars with your eyes at about the distance of about 5.5 feet. So this is about a picture of what it would look like if you were on Mars. A little bit reddish, as you can see. The sun is pretty low and small, and it's a pretty barren landscape. I think upstate New York is much more hospitable, much nicer to look at. And the thing about this, you could jump, if you were a basketball player, you could really set some world records, but you wouldn't be able to breathe, which was a small impediment. So standing on Mars is an issue. So our grand challenge is the Earth, in fact. And we do have a grand challenge, and it's a challenge of this century. It's a challenge that your lives are going to be wrapped around, whether you like it or not. And the grand challenge is to get in the box. And what do I mean by that? Every dot here is a country in the world. And as the dots move further to the right, the quality of life is going up. So it's really good to be in a country towards the right-hand side of these diagrams, because high quality of life. But the vertical dimension is the impact on the environment and on natural resources. It's like the footprint that you have to deal with in order to have a high quality of life. And as you can see, the African countries are below the line and to the left. The European, North American countries are above the line and to the right. And our whole history of human civilization and growth has been for economic development, human well-being to come into play, use of resources, but it's moved us up into a more consumptive mode. And on a finite planet, at some point, that gives up. So our challenge is to get into that little green box on the bottom right-hand side of the diagram, where you can have high quality of life, good human well-being, plentiful food, good equity, conflicts are resolved, life is good, and yet we can sustain that kind of environment into the foreseeable future for our kids and our grandkids. No country yet is in that box, but to get into there is going to require a lot of knowledge, a lot of learning, a lot of education, a lot of foresight, a lot of sharing, a lot of intellectual capacity, and that is the challenge of our century, because we're going to get into that box, and getting into that box is not avoiding bad things, it's actually creating an equitable, important future for ourselves and for the people who come after us. So how do we do that? Well, one of the important things is of course, knowledge. We need to really understand how things work, what's what's happening, what's in scarce supply, what dangers are on the horizons, what risks we can take and what risks we shouldn't take. And so understanding the Earth as a system of systems really, is what I was trying to do at NSF and in my research work. And it's understanding the Earth as a complex system. Now, if you were to take all the water in the oceans in a big straw and suck it up, you would get that little bubble of water. So there's actually not a lot of water compared with the solid body of the planet. If you take all the air up through the regions that I study in the upper atmosphere and convert it to standard temperature and pressure, it would be that other balloon on the right-hand side. But of course, the Earth's system redistributes the fluids. We have oceans, we have lakes, we have rivers, we have coastlines, we have atmosphere, and we have weather, whose sole purpose is to take energy from where there's a surplus to put it to where there's a deficit, and that's why weather systems exist. And the reason that we've had perhaps more energized weather systems in the recent past is because nature has to convert more energy, move it around. So we need to understand the Earth as a system, a complex system, that's semi-chaotic in many respects, so it's not deterministic. You can't actually exactly predict how things evolve in a semi-chaotic system. We need to learn from the past. So we need the historians too, Jamie, to help us understand what happened before so that we can put it in the context of today and learn from the past. And there's a little hovel that used to be occupied in Greenland. Of course, nobody's living exactly there. So the Earth's constant is change. So to understand the Earth as a system now, we need to recognize that change is prevalent, but that change is not exactly predictable. It changes over time. So we need to understand change and acknowledge change is happening, but we need to be sophisticated in our appreciation of what's going on. And I'm just showing you a picture here that I'm going to return to a little bit later on, because you all know about the sort of global warming, environmental global change issues, and there the CO2 that's produced by fossil fuel emission in the atmosphere warms the oceans and other parts of the atmosphere. So it's important to go back in time and see where the temperature and carbon dioxide in the atmosphere are correlated. And I'm going to show you some exciting work that we supported at NSF that led to that graph, and I'll describe it a little bit more in detail. So we need to understand the system, we need to understand change, we need to project, we need to get in the box. And we're doing it in the context of a globalized society where information is coming at us all the time. I bet there's nobody in this room who doesn't have a smartphone. And it's coming at us in small pieces, in larger pieces, in not always well-modulated pieces. There's a lot of misinformation, there's a lot of good information. So the quality assurance of that emerging knowledge is very important. And we need to look at, we need to participate in modern society. And there's a cacophony of inputs that you're going to get as graduate students. And so one thing I want to appeal to you all is do your homework. Learn in, get into below the sort of soundbite level. Read a little bit into the depth of what we really know, and if you read in, you'll see that there are caveats and some things we don't know. You'll be able to distinguish honest discourse from just soundbite projection of what you must be able to reiterate. And now with your incredible educational background, you're in a position to do that well. So the Earth is a system. So why geosciences? I've gotta give a plug for the geosciences because that's what I'm doing, and why now, and why Earth systems in particular. So I want to show you a little video clip, which I hope will come up.
All Earth systems interact to produce and sustain our elegant planet. Earth science knowledge is the only tool we have to ensure public understanding of Earth and its delicate balance of systems. It's a combination science. It draws upon all other sciences to unlock Earth's mysteries. It surrounds us and includes us. A world in which everyone is affected by Earth's processes and is a guardian of its assets now and for generations to come. We now know that there are some issues that humans will have to address, such as climate change, natural hazards, and the availability of natural resources, such as energy, clean water, and soil to grow food. We also need to produce a new generation of geoscientists, experts who will continue to investigate how
At NSF, we had geosciences. We were supporting a lot of really fascinating research. You get on field trips, you go to interesting places, you study interesting phenomena. But the purpose now that we have, in order to get in that box, is to have a much more holistic, sophisticated understanding of the whole system, which is intrinsically a multidisciplinary activity. So in my talk, I'm going to talk about the priorities that NSF had before I left. Number one was how can we understand and predict the changing environment with its semi-chaotic characteristics? How can we prepare for extreme events and improve resilience so that society can manage itself well? How can we protect and sustain life? How can we achieve, and rather than sustainability, we've kind of used this awkward word, and bear with me, try it a few times, it gets better with time, thrivability, and the concept here is a sustained world could be a pretty miserable Blade Runner, if you've seen that movie, it could be pretty bad, but sustained. But we want a world in the box where we can thrive and flourish and enjoy the quality of life. And so achieving thrivability for all is an important aspect, and not just for the North Americans. How can we engage, inspire, and energize human capital and capabilities? These are big challenges, and we can't do it in individual departments, silos of knowledge with their own journal articles. We've got to actually open up the porous boundaries of knowledge and connect across. So I'll give you some examples of what's going on in research, in the research domain in our country. Just some examples. I'm going to go really fast, so don't take notes. Dream on, buddy, everybody says. Not going to take notes. But just get a sense of the sorts of things that are underway now that are opening our whole perspective on the Earth as a system. I think it's a very exciting time to be coming into the professional field. We have, for example, using the IT revolution, a whole new way of looking at the world's oceans. We call it cyber-enabled ocean observing. If you think about the complex ocean system, 70% of the planet is covered with water. What's going on in the column with the biospheric, the fish, the ecological systems, what's going on with the boundary currents, with the wave distribution, what's happening, in fact, at the sea floor with tectonic processes that can lead to tsunamis and earthquakes and hazards there. So we have a new way in the United States, funded in part by the stimulus package, of instrumenting the world's oceans. On both sides of the continent, northern and southern hemispheres, we're going to have more than 400 sensors, real-time sensors, that will allow at your desktop, you'll be able to see salinity, temperature, distributions of phenomena in the world's oceans. So we're instrumenting, for the first time, the world's oceans. It used to be you had to be on a ship, and there was a passage, and you went to a particular place in a particular sequence. Now we're instrumenting the world's oceans, and that's going to be with us for the foreseeable future. Part of that is a coastal cabled observatory off the Pacific Northwest with a big cable which is capable of transmitting huge quantities of data. So there's seismographs down there. There are commandable gliders that can move around, can move in and around and observe things. And there will be machines that go up and down on cabled arrays, beam back to home via satellite links. So we're looking at the world's oceans in a brand new way. And these instruments are being deployed now and will come online in the next few years. We're also doing the same on land with something that's called the National Ecological Observatory Network. This again will be many, many hundreds of sensors that will be looking at the function of ecological subsystems, forests, landscapes, watersheds, etc., with a quantity of information that we've never seen before. One of our challenges is going to be actually managing that flow of data. Huge volumes of data coming at us. How do we sort and sift? How do we mine that data to tell us what we really need to know in terms of trends and actions? But we're becoming much more sophisticated about monitoring and measuring the Earth as a system, and that's an exciting new era for science, technology, and for getting us in the green box, as I mentioned. The other part of it is, of course, observing from space, and this was my own research field. We have a bunch of satellites up there looking down on planet Earth, measuring many things that need to be measured to determine how the Earth systems. And I just have to throw in my own satellite. It's called the NASA timed satellite. Just between you and me, it was Tim and Ed that put that acronym together for the NASA Time satellite. And there was the launch there, and we're generating global vector fields of winds in the upper atmosphere. This is about at 95 kilometers altitude, and that's working today. And as I speak, the telescopes are going up and down, measuring the moving atmosphere at high elevation. So we have new technological means of understanding planet Earth. And that's very important, because to predict and understand, you need to be able to measure and determine what the status is. And in the world's oceans, we're also doing this. Now, each of these red dots is a voyage on a ship where somebody threw across the side a flotation device that goes up and down in the column and beams back home to space. And you can see that over time, with all these vessels of opportunity, we filled the ocean with these instruments that are telling us, for example, they're beaming back home. They're telling, and this is the current distribution. Well, as of May 2012, the last time I looked, this is where all these sensors are around the world's oceans. And more than 50 NSF awards, many graduate student projects involved in this. And it's telling us what the temperature of the world's oceans are. There are thermometers, amongst other things, on these. So we have a very good real-time way of determining what the Earth is doing and telling us. The other revolutionary aspect is big computing, and what I like to call a new era of simulation. We have big supercomputers now that are able to have names like teraflop machines and petaflop machines that can do enormously complicated calculations on time scales that are reasonable for graduate students to do studies. And for example, the sunspot picture on the top left is the most elaborate simulation of a solar sunspot ever created, and it's a computer product. It's a product of a model working on a computer. And the picture on the lower right is ice changes as determined by global climate models and circulation patterns in the ocean, including the current systems like off the coastlines. So we have a new era of simulations. We're going out and measuring. We got multiple sensors. They're coming back in. Lots of data coming in. We have new computers like the Supercomputing Center opened up last year in Wyoming, which is actually the first such installation in the whole state of Wyoming. And why was Wyoming picked? Because energy costs are low. We can use wind-generated power to run these computers. And that computer will be a world-famous computer because it'll be predicting the Earth system at temporal scales and spatial scales of meaning to people who live in regions, such as the Finger Lakes, for example. So we have these revolutions taking place, and as these tools get more sophisticated and more ubiquitously deployed, we get more sophisticated in the way we can integrate across the disciplines to create this knowledge that's needed to understand the Earth as a system. And this little diagram shows the growth in the last few decades of our ability to conceive of models of the Earth as a system that include nowadays the marine ecosystems, the ice sheets coming and going, the role of carbon cycles, the biogeochemical cycles, biodiversity, aerosols, little particles uplifted into the atmosphere, interactive vegetation. You can use these models to see how forest systems change over time with different projections. So the point is, we're making use of these new assets to have a much deeper understanding of the Earth as a system. And this is actually a historical time, because that deep understanding of the Earth as a system is not only interesting and intellectually rich, we actually need it in order to get into the sustainability, thrivability box that I started with. Because if we don't understand and we can't predict, then we're just really going by the seat of our pants in terms of decisions, in terms of societal issues, important issues. So we make use of these air and sea assets. Graduate students entering the professional field now will have these assets available for them. For example, we need to look at scientific issues such as sources and sinks of cloud, aerosols, climate feedbacks, including the role of biosphere. In one of the congressional testimonies, I showed a movie where a big forest fire in China was delivering aerosols all the way to the continental US and the West Coast. And that was very interesting to people because it really reinforced the sense that the Earth is a system. We are not actually separatable in that sense. So we need to understand and make use of these assets, including aircraft, ships, and the like. And this is one of the things that I'm actually pretty proud of. It's a vessel that was funded by the stimulus package, and it's the first new ship for science in 30 years, conceived of, built in Wisconsin for science, and it'll go to the Arctic region where the sea ice is getting thinner, and it will be a famous platform because it'll look at all of the ecological aspects and the biophysical aspects of the change that's occurring in the high Arctic. It was launched in 2012, and if I'm lucky, I'm going to be able to show you the launch. Scientific ship sideways. I had no idea it would be launched sideways, and of course it looks like it's going underneath, and I need to go back and let it go again and again and again if I'm not careful, and you don't want to see it again. But that ship was launched last year. It's going to make its way to the Arctic, and one of the things I'm very proud about is it's ADA compliant, which means that when I'm in my wheelchair, and if I'm still in active scientific research, I'll be able to go on that ship to the high Arctic and conduct experiments there. So we have these new facilities, ships, aircraft, computers, instrumented, and the US is working collegially with many nations in terms of building this knowledge base. So that's important, and it's an important aspect of it. We also need the people and investigators to do interesting things. And here's an example of such an investigator who was invited into the White House and given the presentation of the top award in science for early career investigators, the P-Case Award. And she was working on records of ancient fossil records from the Caribbean and the Pacific regions, and was able to put together in her work this incredible record of climate history of planet Earth over the last 1,000 years. And every upward spike is an El Nino, every downward spike is a La Nina, and what you see is that this semi-chaotic but quasi-repeatable cycle of naturally occurring changes in planet Earth. No one cycle replicates itself next time round. So, and this is all natural. This is not anthropogenic. This is not human-induced. This is the record that she was able to find of the El Nino and La Nina circulations over the last 1,000 years. So every few years we go into a different weather regime, and the weather gets weirder or less weird depending on where you are. And so this is the signature, if you like, the fingerprint of how the planet operates naturally, unconstrained by human intervention. And of course, we're trying to see now what humans are doing on top of this semi-chaotic, which is the reason it's difficult. It's a reason there's a lot of debate and discussion about change and what's happening, and people talk about different time scales and different periods, and you've really got to step back and look at the whole system really to get the detailed understanding. And that's why I really recommend a lot of reading. So now, another investigator went around the world on these voyages and conducted experiments all the way around the world to look at the relationship between ancient CO2 in the atmosphere and temperature in the atmosphere. And this is the diagram I started with. And you can see that this is new work, just came out in the last year or two in Nature, April 2012, so just about a year ago. And it shows pretty conclusively through these global observations, integration, computer models, of course, associated with them, ships that drill into the subsea floor, bring up material which goes into isotopic records, conclusively showing that CO2 led temperature changes. So as the CO2 changes, the temperatures follow later on, with a lag of about 500 years, in fact, for this ancient record. So this shows some relationship between atmospheric constituents and temperatures. So we need this understanding. We also need to prepare for extreme events and improve resilience. Hazards is very interesting. We see hazards. It's a diversity of phenomena. Again, it's intellectually rich. We need to bring physical understanding and social sciences together. And there's another talk I like to give that's called The Coming Collision. It's the physical science and the social sciences coming together around problems at levels that we haven't really been able to do. And that's where comprehensive universities can really play a major role in interdisciplinary thinking, generating the kind of willingness to cross intellectual party lines, if you like, to work across the social physical science barrier and hazards is a great place to do that. For example, when the Deepwater Horizon oil spill happened, we went out and made observations. We had a robotic camera-driven sensor here that's called Sentry. It's an underwater vehicle, not manned or not staffed, in the Gulf of Mexico. And just after the oil spill and published online in August, before the well was actually capped, this vehicle had sort of done zigzagging tracks around the spill, and it really quantified the extent, distribution, and spatial evolution of the spill. So this is science in service of society, figuring things out, being quantitative, being analytical, observing, monitoring, measuring, trying to understand. Another example is in response to the Haiti earthquake. When that happened, a lot of loss of life, but it was actually a relatively minor earthquake. The problem with Haiti is that there was no codes developed there, so a lot of the buildings didn't make it through that earthquake. We learned shortly after that happened that there were no seismographs in the Caribbean basin to speak of, or very few permanent installations of seismographs, and yet this is a region of the world that's threaded by faults, and a lot of people live there, so there's a lot of societal hazard in the Caribbean. And so NSF was able to fund, again with funding from the National Science Foundation, standing up a 50-station GPS weather network to provide early warning of seismic events in the Caribbean, and that's being built as well. And they have the award, in my mind at least, for the best acronym, and they call it COCONET. Don't ask me for what it stands, but the Caribbean Basin is going to be protected by an array of instruments that will help people prepare for seismic events. Then for things like volcanoes, the big volcano that went off in Iceland, you may remember this. Every dot here is actually an aircraft, a real aircraft flying on that day. You can start to see the volcanic ash lofted by that volcano and moving towards initially Scandinavia, but then down across Britain and into France. And what you see, if you keep watching, you'll see the interruption of airplanes, domestic airplanes, that happening about now. See, Britain is shut off. And actually the economic cost, just for those few days, of the interruption in commerce driven by aircraft was of the order of somewhat under $2 billion airline industry, just airline industry lost, let alone the economic loss there. So here's an example of nature doing something, impacting enormously on economic development and on transportation in this instance. And so we need to understand the prevalence, the likelihood, the impacts of these kind of things. Superstorm Sandy hit, and I was asked to join the Governor's Commission called the NYS 2100 Commission to provide recommendations to improve strength and resilience of the Empire State's infrastructure. And this commission worked between Thanksgiving and Christmas without hardly a break. Many SUNY faculty were involved in developing the bibliographies, and it's about a 200-pager. You can find it online. But the thing that I'm very proud about, and that the governor talked about in the State of the State, Governor Cuomo did, is that rebuilding is not just about reinforcing the status quo, it's about being smart. Sometimes withdrawing is the smart thing to do, not rebuilding in the same place, which is prone to damage. And I think we're becoming much more sophisticated in our thinking about how to respond, how to adjust lower risk, still rebuild, but rebuild in a smart way so that we have wetlands that can provide buffers for future storms, etc. So all of this requires science, technology, education, social science, and also communication. because there's so many vested interests in what to do and how to do it, and that if society is going to be making smart, informed decisions, we actually have to start trusting each other at a level and recognizing quality in terms of scientific understanding and knowledge. So how do we protect and sustain life with hazards and so forth? Well, we need to worry about things that will happen. And in Cascadia, the Pacific Northwest, we're likely to see in the next 300 years a tsunami. So we need to get ready now because if you look at our understanding of Cascadia, and here are some ancient records in Japan and the way tsunamis propagate if there's a big earthquake off the northwest coast of the United States, which is where our subterranean cabled observatory is, you can see that the waves would make it all the way to Japan. And in Japan in 1700, there was a big tsunami. A lot of damage was done, a lot of lives were lost. There's historical records of it, ascribable to an earthquake that occurred off the coast of the state of Washington. So now, how often do these things happen? Well, you go and you make your drill holes, you bring you take your graduate students, they make their observations, and this record here on the right is a record of about every 300 to 500 years, there's a tsunami that's associated with a major earthquake fault. So we need a readiness to respond to those kind of hazards when we have information like this that provides some level of predictability. And then there's just the exciting knowledge exploration that's also part of this whole story. And one of the questions that we pose is about life. And obviously a first order question is how much life is there? And at NSF we have a drilling vessel that can go out into the drill below the deep sea floor. And this is backdrop of this picture is an image, it's a photograph of a sample that came up from the deep sea floor, a kilometer below the sea floor, brought up, so that level is about as old as 100 million years, 111 million year old, and found there are living prokaryotes. So we have life below the sea floor at very hot temperatures, as hot as 60 degrees centigrade. We wouldn't find that kind of life on the surface. So we don't know actually how much life there is on this planet. I think we can guess how much life there is on Mars and be probably pretty accurate, but we don't know today how much biomass there is on this planet that we inhabit. So there's a lot of exploration to do. Water is going to be another major issue. What happens after the precipitation fails? So I did teach atmospheric science for 20 plus years, and the dirty little secret of atmospheric science and meteorology, I hope I'm not goring anybody's ox here, is we're very good with frontal passages. We know where things are going and where they're going to be shifted, but how much H2O comes out of the sky, our skill is only about 30% after 40, 50 years of deep analysis. So quantitative precipitation forecasting is very hard to do, in part because of these El Nino cycles, because of the complexity and chaotic nation of atmospheric sciences. So, and if you think about it, how much water falls out of the sky is a very important thing to know, because food comes from irrigation, comes from soil, comes from crops, and we're going to have to feed 9 billion people, maybe 10 billion people shortly. So we need to know the distribution of precipitation. So water is very important, which means understanding of the Earth system, sublimation, transpiration. We need to know what drives droughts, what drives famines, how agriculture is affected by changes there. And here's a couple of maps of the sort of state-of-the-art of numerical modeling of precipitation under effects of climate change. And every little red diagram here, where it's white, the models disagree, not just in amount, but in sign, whether it's positive or negative into the future. So our understanding, our in-depth quantitative ability to predict future famines under global environmental change is very limited today, which means that as we take societal decisions, we need to respect that lack of certainty about our knowledge. And that's because precipitation is the hardest thing to do. But water sustainability is going to be very important. Availability, quality, dynamics. So coastal vulnerability, another interesting one for the New York State. And this is a diagram of I remember the Katrina situation with the storm hitting there, and now we're reinforcing the Mississippi. I think we might have done that wrong by reinforcing the status quo, not allowing the delta to grow. All the silt that flows down the Mississippi flows faster and faster as the walls get higher and goes out beyond the continental shelf, which limits our ability to build new land in the delta. And in fact, of the world's deltas, maybe 28 deltas around the world where 2 billion people roughly live, they're all subsiding. So look at deltas as a place where global environmental change, earth systems, and human welfare and well-being really come into focus in the next 20 years. Internationally, countries are dealing with these things and a lot of cooperation. And I was involved in something called the Belmont International Opportunities Fund, which got stood up last year. 2 initial projects, coastal vulnerability and freshwater security, commitments from 11 countries to co-invest in basic research, 22 million euros, I don't know why it was euros, but it was at the time. Scientists from 140 countries proposed. So we have a global village of science and technology that's willing to work together across country boundaries. And I think that's very exciting, a new kind of way of looking at the world through collaboration. And in fact, in all of science and technology today, fully 1/3 of all the papers are internationally collaborative. That means co-authors come from different countries, not just different institutions or departments, different countries. So collaboration, collaboration, collaboration is important. And this group has set up a 10-year initiative. It was announced at Rio +20. It's called Future Earth. So look for Future Earth. It's an alliance between the UN bodies, UNESCO, United Nations Environment Program, United Nations University, funders, and the top bodies in science and social science, all coming together saying, we need this body of knowledge in order to make sound societal decisions moving forward. I think that's very exciting. In our country, there's federal leadership. If you read the small print of the, well, not small print, of the President's budget request to Congress, very exciting to me. You can see the sustainability initiative. I've given you examples of that. The budget request from the President to Congress has that growing 50% to $223 million per year for sustainability research in the United States. Now, whether that happens or not will play out over time. But I hope with me you can find it in your hearts to support that piece of the President's budget. Even with budget problems, we need to make investments in this knowledge that's going to be so central for future human well-being. And then finally, we need to engage, inspire, and energize people who are able to do this kind of work, talk about it, share it, get excited. Again, it's not avoiding bad things. This is creating the economy that the world needs, a green, low-carbon, equitable economy that we need. And we need to get there fast, and it needs to be built on knowledge, science and technology, not on guesswork. And so we need to train people like yourselves to educate them with the ability to work in teams, to collaborate, to present like today, to understand, to be able to articulate what's been learned. And here's an example from my own field, satellites. And we need to do this as well, recognizing that a lot of underrepresented groups need to participate fully in these research. And we had programs at NSF that were really all about broadening participation in the geoscience workforce. And as President Obama said in one of his speeches, we need all hands on deck to solve these kinds of socio-technical problems, and we just simply cannot afford to leave behind major components of our community. So we have programs like Ocean Leaders, going out, doing things, throwing things off the side of ships, studying fossils in the field. It's a great thing to do. And of course, I think we all recognize that particularly as you begin your career, networking, interdisciplinary, collaborative ventures are important. So yes, you need disciplinary depth and breadth and insight and tools, but be open to working with others. Don't take no for an answer. Conventional wisdom is not always right. It may be an El Nino, La Nina, not a synoptic thing that... So we need to bring together networks, and because of that, we're looking at new information technology. Social media really is a great tool for internationally collaborative work on Earth systems. So we're building something called Earth Cube, which will do that. So I'm about to end here. I know I've covered a lot of ground. I've talked a little bit about human capital, a little bit about IT, the need for interdisciplinary, interagency, international facilities, measuring things, monitoring things, new initiatives, the role of discovery, and all of these programs exist. And what we need to do now is we need to take all of those programs and start building the connections across and among them. And I would say that we also, Adrian, we need dance in there, we need poetry in there, we need ethics in there, we need languages, we need arts and humanities, we need the liberal education problem-solving perspective, because with all hands on deck, these problems are not going away. They're getting more and more significant, and if there's going to be an equitable future for humanity, we need to do this really well. So no pressure on any of you graduate students. There's nothing we're going to be demanded of, but this is your time, not ours. It's your watch now. So society demands reliable projections of coming changes. In some places we can do it well, other places we have problems. People are making unprecedented changes in the Earth system at an unprecedented pace. It's almost like a race between the need for the knowledge and the growth of that knowledge. And, you know, actually, not that religious person, but I think it's amazing that that crossover, the need for the knowledge and the emerging of the knowledge, is occurring on our watch, on our time, at these institutions. So that's a very big responsibility for us. Because we could have had this knowledge 150 years ago, or we could never have had the knowledge. But it's emerging just at the right time. So we cannot predict by extrapolating from the present or the recent past. So we must be honest and cogent and careful. We must identify and understand key Earth system processes using all the tools at our disposal, models, observations, and experiments to make smart decisions. And that's simply what we need to do. It's also, incidentally, job security for people who are well educated in the United States, because this is what it's going to be about, is this jigsaw puzzle of a planet that supported the growth of human civilization and the knowledge that's emerging to maintain and manage that in a way for future human well-being. And it's got many components, this jigsaw puzzle, but notably biology, obviously, but chemistry, physics, dynamics, meteorology, and also social sciences, how humans make decisions under risk and uncertainty. And my last picture, if we could turn the lights down a little bit here, Matt, I don't know if we can do that, I'm not sure this is going to work. We've got to get the lights really low. But what you're looking at here is not space art. I am a space scientist. At University of Michigan, we built an instrument that got launched on a satellite that went to Saturn. It was called Cassini. It was actually pretty controversial at the time because it had a nuclear reactor on it when it got launched. So there was a lot of delays, but it finally got launched. It flew, took several years to get to Saturn. It flew through the rings, this little thing, and we built a piece of it in our laboratory. And then when it got to the other side of Saturn, it took this picture, looking back towards the sun. So the sun is behind Saturn, and so that's why you see it's kind of illuminated around the edges. Saturn is in eclipse. You're looking back at the sun from the other side of Saturn, and it's not going to work because of the light. There is a little dot there. So if anybody wants this image, I'll get it to you. You probably can't see that little dot, but it's there, I guarantee you. That's Earth. And so that's a real picture taken a few years ago, and that little dot contains all the music that's ever been written, all the history books that have ever been written, all of the meals that have ever been, all the keynote talks that have ever been done, and everything that you might want to do with your lives. So perspective is very, very important. We have that planet. Mars is not going to pass muster. We have this planet with all of its complexity. We're now instrumenting it with a view to creating a future that will work for humanity. And if that's not as noble a mission as you can imagine, for all hands on deck, where we need the humanists, we need the people who can express human aspirations and the human experience just as much as we need the pointy-headed space scientists like myself. So I'm going to stop there and thank you for your interest, and And thanks for inviting me, Professor Halstead.
So folks, thanks again, and I hope that you'll attend the rest of the day's sessions. There's plates of cookies here. Please feel free to take those. Feed them to families and kids, and we'll see everybody here later at 4:30 for the post-conference reception.